Moving up, we go to the next one. We're going to go up to 20. 11. 11 is prime. Okay. Then we're going to hit 12. 12 is also a little bit interesting. I know it's divisible by 2, so 2 is going to be one of the prime factors. But 6 is not a prime number. But if I look back here at 6, its unique set of prime factors are 2 times 3. So instead of saying 2 times 6, I write it as 2 times 3. And as you can see, 2 times 2 times 3 is the unique set of prime factors for 12. Now here's where you learn about grouping and commutative properties. We can group that 2 times 2 is 4, so 4 times 3 is 12, or we can say 2 times 3 is 6. That is also 12. Moving to the next number, we come up with 13, again, prime. Next number up is 14. I know it's even, so I know 2 is going to be one of the factors. And 3 doesn't go, 5 doesn't go, but you know what does go? 7. There we go, 2 times 7, unique set of prime factors for 14. Next number up, 15. Not even, so I know 2 doesn't go, so I have to ask myself, what is the next prime number up from 2? If I look back over here, the next prime number up from 2 is 3. Will 3 go into 15? It does. Okay, so I know 3 times 3 doesn't work. Will 3 times 5 work? 5 is the next prime? Yes, it does. 3 times 5 is a unique set of prime factors for 15. Now here's a really interesting one. 16. I know it's divisible by 2, but 2 times 8, do I have 8 back here? I do. And 8 is 2 times 2 times 2. Now something you might see, and you will see actually, in IXL is they might, instead of writing it as 2 times 2 times 2, they might write it as an exponent. Well, as you know, the base of an exponent is the number being multiplied by itself repeatedly. And then the power is how many times you see it. You see it 1, 2, 3 times. So 2 to the third power is 8. So I know that 2 times 2 times 2 is 8. So I'm going to put that right here. So I got 2 times 8, which is 2 times 2 times 2. But again, in IXL, they might write that as 2 to the 1, 2, 3, 4, 2 to the fourth power. Next number up, 17. Hold on, we're almost at 20. We're almost there. 17's prime. That was an easy one. 18 is even, so I do know that 2 is a factor. Okay. And I know it's 2 times 9. And if I look back over here, how do I write 9 as primes? Well, 9 is just 3 times 3. Or you might see that written as 3 to the second power because there are 2 3's there. All right, so we got 2 times 9, which is 3 times 3. Now, that might be written as 2 times 3 to the second power, or 3 squared. 19 prime. All right, almost there. 19 is prime. And 20, where we're going to stop, is going to be, we know it's divisible by 2, so 2 is one of them. And I know that 10 is in there, and if I look back over here, 10 is written as primes as 2 times 5, so I know I can do that. So I'm going to have 2 times 2 times 5, or 2 to the second power times 5. Now you could keep going. You know that 21 is 3 times 7. 22 is 2 times 11. 23 is prime. 24 is 2. We know that 24 is 2 times 12, so that's going to be 2 times 2 times 2 times 3. 24 is 3 times 8, which is 2 times 2 times 2 times 3. 25 is 5 times 5. 26, 2 times 13, and then on. And you can break any number down that's greater than 2 into its unique set of prime factors. And later I'm going to show you how you use this knowledge in order to simplify radicals.